Hello everyone, this is Harshita Aswani. So in this video, I'll be talking about how I created a regression model for prediction. So first of all, I imported some necessary libraries such as NumPy, Pandas, Seaborn, Matplotlib, and then I imported label encoder, which is quite essential for feature engineering. And then I imported train test split, linear regression, decision tree regressor, random forest regressor, gradient boosting regressor, and for the evaluation metrics I imported mean square error, mean absolute error, and then I loaded the dataset. Here you can see the dataset, and then I checked the first 5 rows by using the head method, and then I checked the last 5 rows by using the tail method. And then I checked the data types of the columns by using the info method. Here the data types are given of each column, and then I also checked the null values. Here we can see that all the values are non-null. Here I checked the unique values in each column. Here age is having 47 unique values, sex is having 2 unique values, BMI is having 548 unique values, children is having 6 unique values, smoker 2 unique values, region 4 unique values, and charges 1337 unique values. And then I checked the column names by using the columns method. The column names are age, sex, BMI, children, smoker, region, charges. And then I checked the duplicate values. Here we can see that in front of one true is given, showing that there is one duplicate row. So what I did was I just dropped the duplicate rows by using the drop duplicates, and then after dropping the duplicate row I checked the shape once again. Here you can see the change in the shape from 1338 to 1337, and then I checked the size again, and then I looked for the outliers by visualizing the age, BMI, children, and charges in the form of a box plot. Here we can see that in the column BMI and in the column charges there are so many outliers, while in the column age and in the column children there are no outliers. So next I just removed the outliers, and then after removing the outliers I created the box plot once again for checking if there are any more number of outliers or not. And then I used the describe method for getting the statistical summary of the age, BMI, children, and charges. Here we can see that in the statistical summary I got the count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and the maximum. And then I calculated the total charges by region for creating a bar chart. Here we can see that there are 4 regions: northeast, northwest, southeast, southwest, and the total charges are given on the y-axis. And then I created count of smokers by region. The orange bar is showing if the smoker is yes smoker, and the blue bar is showing that if the person is not smoker. And on the y-axis regions are given such as southwest, southeast, northwest, northeast, and on the y-axis count is given. And here I created a pie chart showing the distribution of smokers. If the person is a smoker, then the pie chart is showing the orange color, and if the person is not the smoker, then the pie chart is showing the blue color. Here we can see that 93.4% are not smokers, while 6.6% are smokers. And here I created a violin plot showing the charges by number of children. Here on the x-axis there are number of children given, such as 0, 1, 2, 3, 4, 5, and on the y-axis charges are given. And then I created a count plot showing the distribution of gender. Here the orange is showing the male, and the blue one is showing the female, and on the y-axis count is given. Here I created a histogram showing the distribution of age. Here on the y-axis age is given, and on the x-axis frequency is given. And here I created a histogram showing the distribution of BMI. Here on the x-axis BMI is given from 15 to 45 and more, and on the y-axis frequency is given. Here I created a scatter plot showing the relationship between the age and the charges. Here we can see that on the x-axis age is given from 20 to 60 and more, and also less than 20, and on the y-axis charges are given. And here we can see the trend in this scatter plot showing a positive relationship between the age and the charges. And here I created the charges distribution for smokers and non-smokers. Here we can see that the no is given here for non-smokers and the yes box plot is given here for the smokers. Here we can see here that on the y-axis charges are given. And then I performed the feature engineering by creating a new column known as age group. And then I performed the feature encoding on the column region, and then I used the label encoding for the smoker column and created a new column known as smoker encoded. And for confirming all these changes I used head method for checking the first 5 rows. Here we can see that the new column, that is age group, is created showing young, adult, and then region northeast, region northwest, region southeast, region southwest. 4 new columns are created by using the one hot encoding, and then the smoker encoded column is also created by using the label encoding. And then I performed the correlation analysis for selecting the relevant features. After performing the correlation analysis, these two features are selected as the relevant features, such as the age and the smoker encoded. And then I used age and smoker encoded for X, and I used charges for Y. And then I split the data into training and test set, and then I created the linear regression model, decision tree model, random forest model, and gradient boosting model, and then I visualized all 4 models actual versus predicted values. So here we can see that the red line is showing the predicted value and all these blue dots are the actual values in the linear regression model. In the decision tree model, all the green dots are the actual values while the red line is the predicted value. Here in the random forest, all the yellow dots are the actual values and the red line is the predicted value. Here in the gradient boosting, all the purple dots are the actual values and the red line is the predicted value. And then I printed all the evaluation matrices of all four machine learning regression models, such as the mean squared error and the mean absolute error of linear regression, decision tree, random forest, and gradient boosting. And then I visualized all four. Here, here we can see that this is the visualization of the mean squared error for all the four predictive models, such as the linear regression model is having the maximum mean squared error, while the gradient boosting model is having the less mean squared error. In the next plot, here we can see that the linear regression is having the maximum mean absolute error and the gradient boosting is having the minimum mean absolute error. And then I interpret the all four models by calculating the intercept and coefficients of the linear regression and by calculating the feature importance of the decision tree, random forest, and gradient boosting. And after that, I plotted these interpretations. Here we can see that this is showing the intercept and coefficients, and this is the feature importance of decision tree, feature importance of random forest, feature importance of gradient boosting. And then I used an example input for the prediction in all the four models. So as example, I took the age 30 and smoker encoded 1, and then the linear regression predictions calculated 18,250, decision tree predictions calculated charges 19,323, random forest predicted charges 19,201, gradient boosting predicted charges 18,919. And then by using the MSE values, that is mean squared error values and mean absolute error values, I calculated the best model, and the best model calculated was gradient boosting. So I used gradient boosting for next example input, and by using gradient boosting I calculated charges for various different types of examples. So this was all about my regression project. Thank you so much for watching till the last. I hope you enjoyed this video.
If you like this video, give thumbs up and subscribe if you are new on this channel.